Okay, AQA Physics, June 19, paper 1, question 2. Okay, so scientists cooled the air inside a container. Okay, so it's getting colder. Temperature of the air changed from 20 to 0, so it's gone down. The volume stayed the same. Explain how the motion of the air molecules caused the pressure to change. So you need to know this. You need to know that you've got a box, and inside the box you've got particles, and if it's a gas, they're whizzing around, and pressure is caused by them hitting into the walls of the box. So what does the effect of it cooling down have on how they hit the inside and therefore the pressure? Well, you should know that if it cools down, that means they're going to go slower, and if they're going slower, they're going to hit the walls not as hard, and they're also going to hit the walls not as often. So that means the pressure goes down. So a simple answer, just using bullet points, is that the particles will move slower. That means they will hit less hard. There's motion detectors at my front door. They'll hit less hard, and that will cause lower pressure. Right, next part of it is the air contained water that froze at 0 degrees C. Change in internal energy, okay, right, was 0.7 kilojoules. So that's going to be my energy. Don't know what type of energy, but just go with energy for now. And I would normally be tempted to change the kilojoules to joules, except I've noticed that the next bit is also in kilojoules. So for this once, I don't need to. I could, but I don't need to. I also look at this, it says specific latent heat of fusion. Now, I know that specific heat capacity and specific latent heat are both on my equation sheet. So I check the equation sheet, and you see that the equation you get is that E equals mL. And the equation sheet tells you that L is the specific latent heat. So that's L. Suddenly this becomes quite simple. E equals mL. 0.7 kilojoules equals the mass times 330 kilojoules per kilogram. So the mass is 0.7 divided by 330. And that comes out at 0.0021 kilograms. If you're having problems rearranging or changing the subject of these formulas, you need to practice and you need to ask for some help. Okay, next part of the question. Right, this caused a lot of problems. Hardly anyone got this correct. It's meant to be quite straightforward, but it obviously wasn't quite straightforward. So let's have a look. It tells you some temperatures that things boil and things freeze at. It also says something about sublimates for carbon dioxide. That's a bit different. So let's have a look. If you know something's boiling point and something's freezing point, there we go, and you imagine like a number line, if you're above the boiling point, you're a gas. If you're below the freezing point, you're solid. And if you're between the two, you're obviously a liquid. Now the only thing that throws us here is this thing about carbon dioxide sublimating. Where's it gone? There you go. Carbon dioxide sublimates. If you remember, that means that it's never a liquid. It just goes straight from a solid straight to a gas. So you're just trying to work that out in this one. So you look at the temperature Oxygen boils at minus 183 and freezes at minus 218. So at minus 190, that is between these two numbers, and if it's between the two numbers, it's a liquid. The nitrogen boils at minus 195. Well, minus 190 is warmer than that, so it's above the boiling point, it's a gas. And then finally, carbon dioxide sublimates at minus 78 degrees C. So that is a temperature that is much, much closer to zero and therefore warmer than minus 190. So it's a solid. That was supposed to be an easy question, but I think it confused some of you, so worth practicing and thinking about. Right, I think this is the final part of 2.4, and they just want to know about the particle model, but you need to say what's happening and why at each stage. So really what you need to talk about is that it cools, because we start with a gas. What's happening as the gas cools down? Then it changes into a liquid, so what happens as it condenses? Then it cools some more. Then it freezes, and then we've finished. So what happens at each of those stages? There were loads of things that you could say here. Let's start with cooling. So as it cools as a gas, you've got to say what the particles do. The particles, we know the questions about the particles, so here, particles, they slow down. Might need to connect that to what we know about energy. So why is that? As temperature is the average kinetic energy of the particles. And as they slow down, they're going to get closer, which I can't spell. There you go, closer. Then it condenses. So that means changing into a liquid. So they're now touching and moving past each other. So if they're touching, moving past each other, there are stronger forces between them, between particles. And then finally, it freezes. And when it freezes, just describe what the particles are doing. So the particles are now fixed in place. I've just written fizzed. Fixed in place. Vibrating. And we could say there are now strong forces between them. Let's be fancy. Intermolecular forces. And that's it. That should be 5 or 6 marks for that question.